So let's get started. So again, I want to let's discuss exam. When do you want your exam? Next exam, next test. So you'll have 2 more tests and the final, and we'll take best 2 out of 3. So when do you want your next test?
We have
Next Friday.
next Wednesday. We have it
don't
on
have
the
class.
7th. November 7th.
Why are you correcting me?
What is today?
November 7th. And why are you correcting me?
Today is 23rd, right? Today is 24th.
Right.
So you want it on 2 weeks from now or a week from now?
2 weeks.
November
Wait,
7th.
no, one day because we need to squeeze another test somewhere.
You need to squeeze it.
I know we can squeeze another test like boom, November.
Well, the
21st.
21st?
Your let's look at when is the Thanksgiving break?
21st.
Oh, that's the week.
So we need one before Thanksgiving break.
Dr. Sen,
Yes.
you said best 2 out of 3 and does not include the final and the mid-first, right?
Final and midterm are mandatory.
Okay.
The whole week of November 18th is Thanksgiving break.
That's when it starts.
Yeah.
18th, that's a Friday.
No, it's a Sunday. November 18th. We have
Okay.
the whole week off.
So let's do the 21st and the 14th. That's 2 weeks. Next week and then 2 weeks away. So we have next week right after that.
Yeah, I think that's 18th means
Next Wednesday. On December something.
Wednesday.
After the week.
Is this okay?
No.
Friday?
No.
Are you guys going to be here Friday?
That's a Wednesday.
I'll be here Friday too.
That's the worst.
How many want to take it Friday? How many can take it Friday?
What time?
This Friday?
Huh? Not this Friday.
Next Friday.
Huh?
Not this Friday? Next Friday.
Not this
That'll
Friday.
be November 2nd. Next Friday.
Now we can take November 2nd.
Huh? Alright, let's do it first Friday, okay?
It's November 2nd. Isn't that Dr. Sunday? Okay, it's Friday, but I think it on the 31st.
Yeah, if you want to take it early, you're more than welcome. That's not Huh? I'll post the homework today. I forgot to do it yesterday. Yes.
Because that exam is scheduled on Friday, you still have the Tuesday class?
Yeah, we'll have the Monday, Tuesday, Wednesday class. Okay. What I'll do is
Wait.
so you have
There's another sauce.
let's schedule it for what timing do you want?
Friday?
DBF. You guys are still doing the DBF. How many are the DBF?
9 to 11.
9 to 11. How many are the DBF this week? 2, 3, 4. So can the rest take it from 9 to 10
Yeah. On a Thursday.
on Friday? We'll figure out a timing for DBF. Yeah, we'll use that class. Is that okay?
Yeah.
So we'll have DBF guys. When do you want it? Friday. You'll have to take it Friday itself. So, suggest it. 11 is fine. You have a class at 11.
Oh, you're talking about DBF.
Yeah.
Oh, you're talking about just DBF, right?
Right.
Yeah, just DBF.
You're in DBF.
No, he's not in
Tori's.
You are not part of the DBF team, right? The design build flag. So you can take it from 8:45 to 9. Okay. How many are in the DBF? Just raise your hands.
I can just take that.
Tori's.
Only 4 of you all, right? So you can take it at 11.
Wait.
And
Bro, you're not even understanding.
So it's an obvious DBF.
You have class at 11. What time are you available?
I can take it at 12.
12 is fine.
We got class at 1.
You got that.
12 to 1.
Hmm?
12 to 1.
You want to try and make it at let's shoot for 11:45. Okay?
Yeah, that's cool.
11:45 to
Can I also come out at 12?
huh? Yeah, you have these 2 options. So you can now all of you don't come at that option, okay? Or you can do it at that's fine. Take any option you want. These 2 are the options. Is that okay? You guys are good?
Yes.
Is that a comment on this slide specifically?
And the 18th is a Sunday, right? So we'll do the same thing on 16th November. Is that okay? Before you go out for Thanksgiving break, just finish your test and take it easy for the break. Is that okay? 16th November?
And then come right back in and plan.
Yeah, just prepare for the finals. Okay.
Like 1 would be the
It's not gonna feel without my.
2 would be.
You know what I'm saying?
We'll do the same thing for
They already got a picture of it.
okay. Alright.
Why is it everything so 16?
This is how we want. That's
16th.
16th, that's a
Friday, right? 16th is a Friday.
Friday.
Second is a Friday, 16th should also be a Friday.
Yeah, that works.
Second test. Test 2, this will be test 3. You have 3 tests. You've already taken test 1,
Okay.
test 2, test 3. Alright? So you only 2 out of these 3 will be considered for your final grade. And then you have the midterm and final.
I'm not elected.
Okay? And you have about 6 assignments. You'll have 2 MATLAB assignments. I've already assigned you 1 MATLAB assignment.
They don't even know the purpose of it.
Okay?
No, they got it.
Where's the first MATLAB assignment?
I'll post it algorithm 4.1. Okay?
That's right.
Alright. So we've been discussing orbital elements. Okay? And these orbital elements uniquely identify. Switch off your cell phone. There are 6 elements which are required to uniquely define a orbit. Alright? What are those 6 elements again? Right? So you categorize them into, this defines the size. Next, this defines the shape, right? This is category 1. Okay. Then you have omega. It's the right ascension of ascending node. Okay. Then you have I, which is the inclination, and small omega. This is the argument of
Yeah, I think we get two times.
periapsis or peri.
Because,
These are
it's function.
these define the relative orientation of the orbit. Okay, and finally you have theta, which is the true anomaly. All right.
Could you explain real quick? The cap?
Cap omega. It's called the right ascension of ascending node. Alright?
What was the N?
Node.
No.
Right ascension of ascending node. What are these three? What mathematical quantities are these three? Angles. Angles. Distance. Pressure. Alright? Where is the eraser?
Right here.
Christian too.
Dang, why would I take that rest?
You guys are good with this? Shall I erase this?
Christian is right.
Yeah.
There is you.
Oh, really?
The MATLAB assignment that I argued like whenever we did, right?
I was about to say.
Say that again.
You said the MATLAB assignment.
Oh, that's it.
For review whenever we did them, like it won't.
Right, so I think let's do the MATLAB assignment before your Thanksgiving break. Okay? Or the first one. The second one you can approach it after you come back. Okay? Now what happens is although mathematically these are the unique elements, these are the elements which uniquely define a orbit, you cannot physically measure these. You understand? Can you physically measure these? Can you measure the size of an orbit?
I mean,
You cannot go there and measure it, right? Even when some, huh?
I said we can calculate the math and we cannot. That's
Correct. So there is a limitation with this regard. You can compute it. What you can measure is, so there is something called orbit determination. Okay. This is given R and V in ECI. ECI is Earth-centered inertial, or this is, what orbit is this? Geocentric equatorial frame, or not orbit, it's geocentric. Equatorial frame. Okay. Yes. R is position. This one? Right ascension of ascending node. Okay. Can you measure the position of something which is flying or orbiting? Can you measure it?
No.
You cannot?
Are you saying can you measure something that's moving?
Right.
Yeah, at a specific point. Example.
From,
Yeah.
don't we do that?
We
Don't
do.
we? Huh?
Okay.
Can't we? Can you measure the position of a plane?
Mm-hmm.
How do you measure it?
You use GPS or you use VR?
Depending on where it's at.
What is the question? Can you measure the position or the velocity of a plane?
Yes. Oh, it's about like field track. Yeah, yeah, yeah. The velocity, yes.
Position?
and velocity.
GPS.
Right. GPS is, see, GPS
Get on your squat.
now, it's again, this is what is interesting. Okay, now you bring up a very, can you measure, huh?
Like those plans over.
Yeah, latitude, longitude.
So you can measure like
That is, yeah, I'll get to that. This is an interesting perspective. I think let's have this discussion. Okay. GPS, can you measure the position of anything, of a third body using GPS?
Third body.
Is that a third one? It's just like in your own.
You have to be physically present with that sensor, right?
Yes.
You agree to that? So if you want to measure a UFO flying by, can you do that using GPS? No, right? Unless you put a GPS receiver in there, you cannot measure. But can we measure the position of moon, for example? How do you measure it?
put a receiver on.
Go for a round and cover.
We gotta use math then.
There is always a basis, math, fundamental math. See, fundamentally you cannot start from math. The limitation of math is, there is no starting point. You understand? If you understand the fundamental physics, the most fundamental physics, what is the most fundamental math?
Numbers.
We don't know. Okay. Do we know the most fundamental physics? Yeah, that is what the fundamental is, right? The fundamental is even before that, what is? Huh?
Another force.
Gravitational force, the universal law of gravitation. Laws are fundamental. Okay, we start from now. Physics provides you the fundamental. That is where you start your math. Physics is not a whole lot. You could probably compile all the physics in a few pages. You understand? Math is infinite. So whenever I say, can you measure, that's different from math. You understand? So can you measure something flying by? I think you all should be aware how to do that. Especially you, Torius.
I do this, I say yeah.
Huh?
That's why I say yeah.
How do you measure it?
It's got
Well, you gotta have a receiver on. You
Huh?
have to have something transmitting a receiver.
How else would you measure?
Not like.
You know where it started in an over a period of time.
No, if you don't have any idea that's the reason I'm saying UFO. Can you measure an UFO flying by?
No.
Essentially, yes.
How do you do that?
you like, you know,
Yeah.
You measure it, you see what you take it at 2 different points.
you make
You
it
take it at 2 different points and then you.
put the transponder on.
You're sitting here, or you're standing here, okay? Take your cell phone.
Is it like
Yes.
the sun?
Huh?
Like the sun?
Can you measure the position of, that's the reason I'm saying UFO, moon, planets, can you measure the position sitting where you're sitting?
Wow.
No.
No.
You can do that.
Something to do with light.
Who said that?
Yeah.
Huh?
Radius?
Huh? Laser. Or telescope, a radar. You have to, it's a simple, how does radar work?
I said
Yeah, it sends a signal all the way to what you're trying to measure, and the signal comes back, and the time that it takes it to come back.
Exactly. It's you bounce off of the object moving. Okay. What you do is, if you're here, you're bouncing your radar off this. Okay. It comes off. Right? And you bounce off this, it comes off. the time it takes, you know this distance, you know this distance, right? This is a position, and if you know how much it has traveled in that time, you'll know what is the velocity. We have done that for a long time now. You get it? What is the most common thing you see where you see this?
Like submarines
Huh?
and stuff.
VORs.
What is VOR?
I would say submarine.
It's the thing you use to figure out where your plane is, distance.
Even more common?
I say war, like people like on ships and submarines.
Even more common?
Cars.
Cops. Your cops are always using this. Your cops are the cops are measuring your velocity by this.
With their
This, huh?
So how
It's not a speedometer.
how do you get rid of that?
You have to. How do you get rid of it? That's a good question. How do you get rid of it?
Destroy.
Huh?
Destroy.
Distort it or
Yeah, you have to bounce that off and make it go not back.
have we done that?
Have we done it?
Have we done
Our
that?
military probably is.
Huh?
Our military probably is.
All the stealth,
Yeah.
they bounce off something somewhere else. So that is the reason they cannot detect. So the angle is such that it doesn't bounce back. It goes off somewhere else. The stealth is the stealth aspect.
So
All the B-2 bombers and all that, the surface is such that it either absorbs it or it will give you a direction where it does not reflect anything. It just, everything is gone.
So what's the limit to like radar technology?
Hmm?
Like if you want to how far in like today's technology, how far can radar like go out like?
How far can radar? What kind of
Like 60 miles or something.
what is the source of a radar? Huh?
Waves.
transducer,
Wait.
What kind of waves?
or radio waves.
Not radio. Yeah, they are all electromagnetic waves. Okay. So how far can electromagnetic waves go?
Infinite.
Infinite.
The way, so
But they began
to kind of like,
they began to dissipate after a while,
Hmm?
right?
If they are going in vacuum, they'll go forever.
Swansea.
You see, all the information we receive out from, even from the, forget about the formation of the universe. That information is still propagating. You see, the formation of the universe was captured as light, which is again an electromagnetic wave. It was captured and it went on, right? It is passing, it is traveling. That information is traveling. Is it still traveling?
yes.
It is still traveling. So the light itself, the information is several light years away. You understand? Or this has happened. When you see the images of by Hubble, or that has happened several millions of years ago. But that information is captured. Even whatever we are doing here, this is captured in light waves. And it is traveling. Information is going. So if we can chase that information, if you want to chase that information, you have to be faster than the speed of light. You can go and see that information. You understand? If you can travel faster than the speed of light, you'll know what is happening. That is how you do space travel.
That's how you do
Can
it.
you use the sun as a slingshot to go faster than the speed of light?
Okay? So here, you understand the position. So you have to understand here that you cannot really measure this, but you can measure the position and velocity. Is that clear? If you bounce off, if you use a radar, it will bounce off and give you position. And if you bounce off at two different times, it will give you the velocity. Okay. Now, how do you extract this information out of these two? That's one of the topics of the exam. So I'll just get you started. Okay.
Decision making process. I mean, just like- Actually, there is
So let's say you're given R and B in the ECI frame. Okay. This is algorithm 4.2. Okay. The first step is calculate R. How do you calculate R?
just the magnitude of.
You're right, magnitude, or you just do this. Okay. You have various ways to do that. I'll just give you this. R dot R is R square. Vector R dotted with itself is R square. You take the square root, you get R. This is the magnitude. Okay. And then the second step is V. It's page number 197. Okay. Algorithm 4.2. V is again similar. V dot V. Alright. Now the third step is calculate radial velocity. VR is equal to okay. Now keep in mind we are trying to calculate or arrive at these from R and B. You understand what is the limitation, right? The problem you understand here. The problem is these are the orbital elements, but they cannot be physically measured. Whenever you put something in an orbit, that something is uniquely defined by this. These are also called, some of you who will get into space domain will call these as TLEs, for tracking any satellite. Okay, TLEs. TLE stands for two line elements. Alright, so these are what uniquely define, but we cannot measure these. What we can do is, even with the satellite, we can measure R and B, and the DoD does that on a very rigorous basis. They track even centimeter, millimeter size objects. Okay, so we know R and B. We just sit here, put a radar, send a signal. Once it bounces back. So there is. You've heard about moon bounce?
Moon bounce.
Moon bounce. Yeah. So if you want to, if it's on a very clear day, you can have a very basic setup, a very rudimentary setup where you can figure out where you can bounce something off of moon. Okay, and then it can hit back, and you can know. You can do the measurement of the position of moon.
You said the first two elements were TLEs, or the
All of these.
all.
Okay. How do you calculate this H? Anybody? You remember? R cross V. Okay. Once you have this, what is H?
H is your specific. on. That's where we.
Yeah. It's again the same thing, guys. This applies to every vector. You got it? Every vector can, the magnitude of any vector can be calculated like this. So, we have our first orbital element here. You get it? This is our first orbital element, H or A. Alright?
That's our first orbital element.
Right. How did we define I?
The angle of this animation. It's angle between
It's angle between
H and Z.
H and Z, yes. Good, very good. I is angle between H and Z, right? Now, this H, now keep in mind R and D are in ECI frame. ECI again is this is the vernal equinox, x direction, or I. This is the x axis. We call this the x axis and I direction. Although it doesn't matter a whole lot, but just for x axis, y axis, j direction, or z axis and k direction. What is k direction?
It's the
Z.
axis.
Axis of rotation. Okay, always remember that. This is the vernal equinox. This is the axis of rotation. All right. So your H would be H x I, right? H y j plus H z k. All right. So H z k is in this direction, right? You agree? If I take cosine I, it is what? Or let's look at this. What is H dot K? Can I write it as H, K, or H cosine I?
Yeah.
Does this make sense to you? Or can I write it as H, magnitude of H? This is a definition, right? By definition, this is H, K, and cosine of angle between them. What is the angle between H and K? I, right? What is this quantity? 1, because it's a unit vector, right? What is this quantity? Simply H. You understand?
H.
Alright? Now, cosine I can be written as H dot K divided by H. You got it? And what is this? The numerator. Anybody? The result of the numerator.
Scalar.
It is a scalar. What exactly is it? I'll give you, see if this makes sense.
The magnitude
Is it the projection of H on
This is how fast the axis will rotate. The magnitude of, yeah. H and Z.
This is H, okay? What is K? This is H, right? How do you write K like this? If you want to write K, can I write it as 0I plus 0J plus 1K? Oh, I'm sorry. Okay. I'll just finish with this, okay? Can we write it like this?
Yes.
If I take the dot of these two, so it will be this dotted with this. You with me? That is 0. Right? This dotted with this. That is 0.
Right.
So this dotted with this would be HZ. You got it? And this is H. So you can say I is cosine inverse HZ divided by. You got one more element. We'll discuss the other elements in the next class. Is this making sense? Right?
the difference between these two links on the graph?
So you have, we calculated this, right?
Yeah.
So you're going to get this. Sorry. HX, HY, HZ. You're going to get 3 numbers, right? You put this number here. You put this here
Yeah.
and take the cosine. You're going to get.
Yeah, but Z don't do it, K too.